I'm Anil Kumar, and in these set of videos, we are discussing how to relate price or demand function, cost function, revenue function, and profit. Now, here is the solution for the revenue function. It is part 1 of the question given to us. The question is, if the price demand function is p of x equals to 50 minus 1.25x and the cost function c of x is equal to 160 plus 10x, where x is number of units in thousands and cost is in dollars, determine revenue function and maximum revenue. In the following videos, we'll try to understand the break-even point, maximum, minimum, and the graph of these functions, right? Now, revenue function, let's write it as r of x, is basically equals to number of items. So let's write number of items times the price function or the demand function. Okay, so that is how we define revenue function. Now the demand function is already given to us, so we can multiply it by x. So x times 50 minus 1.25x. So that becomes the revenue function. So we can expand it, get the parabolic equation, which is minus, I'm rearranging it, writing the x squared term first. So x times 50 will give me 50x, and x times minus 1.25 will give me minus 1.25 x squared, and then I'm writing 50x. So I've changed their position also. It's good practice to write the terms with highest degree first. Now that clearly indicates that it's a parabola which opens downwards, right? Let's sketch this parabola and then we'll further investigate. As you can see, it has two zeros. One zero is at x equals to 0. The other one will be 0 when 50 minus 1.25x is 0, right? So let's figure out where the zeros are. So 1 0 is at x equals to 0. The other one is when 50 minus 1.25x is equals to 0. So that gives us a value. We'll take this on the right side, and then we say that means x is equals to 50 divided by 1.25, right? Which is how much? Let's use the calculator. So it is 50 divided by 1.25, which is equals to 40. So we have the other zero at 40, right? So that means we have a parabola which is kind of like this, right? And then it goes kind of like this, right? So this point is at 40. Now we already have a revenue function here. I've written the revenue function factored form and also in standard form. At times they may ask you in standard form, right? Now we need to find when is the revenue maximum and how much it is. To find the maximum revenue, we should be looking at the axis of symmetry for this parabola, right? So that is always midway between the zeros, right? So axis of symmetry, this axis of symmetry will be, let me write down axis now, will be at x equals to midway of zeros means we'll add them, 0 and 40 divided by 2, right? So that gives us 20. So that is the location. And how much will the value be? Revenue will be r of 20, correct? So the revenue of 20 we can find by substituting 20 in the revenue function. So it gives us 20 times 50 minus 1.25 times 20. Bracket close, right? Let's calculate this. So it is 20 within brackets 50 minus 1.25 times 20 bracket close equals to 500. So we get revenue of $500. Remember, in the question it is given where x is number of items in thousands and cost is in dollars. Well, in the main question given in the previous video, I forgot to type this, so I've added it in all these videos now. So So the maximum value for us as we calculated is indeed 500. So that is the maximum revenue. Okay. So this is our revenue function. So we get maximum revenue. So the answer is that we get maximum revenue of $500 when number of items are 20 and says where X is number of items in thousands, 20,000. So that is the revenue in this particular case, correct? Now let's move on to the next part of it, and that is to find the break-even point. Thank you and all the best.